Okay, in this section of lecture, what I want to do is go back and look at map again and just go through a few what I'll call real life examples of map. So when we first introduced it, I kind of made up some obvious examples, some toy problems. And so here I'm going back to the Quicks. This is my solution to the Quicks project and where I used map in real life, for lack of a better term. Now, as I'm going through this, keep in mind you might look at that and say, no thanks, I'll just use a for loop. I did this not necessarily because map is the way to go, but because I wanted to learn how to use map inside of Java for this section of the course. And so keep that in mind. Keep in mind also that, like I mentioned last week, map is a little more friendly to use in other languages. Okay, so remember from Quicks, you had a model, and inside of the model was some raw numerical data. For example, the values on the dice, the scores, the two-dimensional array of numbers that are checked off and not checked off. But what you had to do when you handed that off to the view is you had to convert the numbers into strings. And so that example of converting one type of data into another is a classic use case for a map function. So here is the method that takes the integer values of the dice and turns it into a string array. And so here the dice are an integer array, so we use arrays.stream to create the stream from the array. And then we have the map method. In this case, it's called map to object because it's on the integer array. And then we take each integer in the array and convert it to a string. And then we've got that last piece where you have to turn the stream back into your array object. And so what you want is an array rather than a collection, this is the magic piece of code to do that. And similarly for the scores, you're going to get that same thing, right? You create the stream from the array, you call your map function that converts the integer into the string, and then you recollect it into the array. So this dice values method, if you were writing it from scratch and not putting it into like a framework like I did here, could be as simple as, I'll call it dice values 2. That conversion can boil down to one line of code. And it's that ability to do that conversion all in one big longish line of code that a lot of people like about things like map and for each and inject and so on. Now, as I mentioned before, having to set it up and having to collect it, takes some of the shine off of it. But if this was like JavaScript, it would be something as simple as dice map I. Right? You in JavaScript, your one line would look more like this, and to me that's a clear win. One line, not too long. The key transformation is pretty easy to pick out of that. So you'll find your own style as you go along. Let's look at the roll dice method. Just a very similar take on the same theme. What I want to do with roll dice is I want to create an array with a certain set of values, right? I'm creating an array with 6 elements in it. And so for each array index 0 through 5, I need some algorithm to come up with the value that's going to be in that spot of the array. So what I have here is int stream.range, dice.length, right? So that range method 0 through 6 creates a stream with the value 0, 1, 2, 3, 4, 5. So I get that sequence of values for each slot in the array. And then so for each space in the array, I'm just converting it to a random number, which is what we do when we roll the dice. And then, of course, we have that collection part of Java at the end. So another common classic real use of map here, where the input isn't necessarily data, but just the indices of an array that you're setting up for whatever reason. In the world of web pages, you might be setting up data in a column. For a game, you might like here, you're setting up some random numbers and so on. Now let's switch over to the model for another example. So we have a number of places where we have labels, JLabels. And so in Java, when you're setting up JLabels, you're often creating a label for each of a number of strings. You may have a list of names, so you need a label for each name. Anyway, so a common pattern in a GUI, Java Swing or otherwise, is you might have a list of data and you need to then create the GUI elements to hold that data. Now, I didn't necessarily do that here because there is a lot more pieces of the setup, but I certainly could have. So let's look at what you would do in the simplest case where I'm just creating a label. So I might have an array of strings that come from my data source. Maybe they're hard-coded, maybe they're in a file, it's hard to say. But I have an array of strings, and then I want a label for each string. So I take those strings, turn it into a stream, call the map function, and then for each string I create the corresponding label, and then Java's lovely collect piece at the end. But you get the idea here. These are all examples right in line with how I used map on a regular basis in the web programming world. And I suspect you will see that sooner rather than later once you get out of Java into some other languages. All right, I got one last example I want to go through, and this example is fairly complicated. So if it catches your attention as an interesting idea, we can dig in further. Otherwise, it just gives you a feel for what more advanced use might look like. I did this solely to see if I could figure out how all the pieces fit together. If I were to do this again from scratch, I would just use a nested loop. But it might be helpful to know certainly what is possible. So what we're doing here is we're converting a two-dimensional array of integers. So numbers is that two-dimensional array with the raw data in it, and we need a two-dimensional array of strings that are the strings that show up in the quicks board, or the X's once you've checked them off. One other piece to point out is I've conceptually set up my array that counts 0 to 12 left to right, so just a normal matrix, but you'll remember from quicks the bottom two rows count down instead of count up. So the display values method here does that conversion. Let me see if I can find that quickly. Yeah, display values is just one method here that checks to see if the rows should be counting up or counting down, top half or bottom half. And if it's the top half, then we count up. We just index the column normally adjusted because we don't use zeros and ones, whereas this has the minus in it, so it counts down. All right, so we're going to have two calls to map here because with a two-dimensional array, remember what an array is an array of arrays. So the first thing we're going to do is iterate over the rows. So this gives us a stream of the indices of the row. So row 0, row 1, row 2, row 3. That's what the index here means. Maybe I should have used row number or something like that. And then for each row, I need to convert the data in that row into a different array. So this is going to iterate over the data in the row, the actual numbers within each row, and it's going to turn it into the string we want to appear. So this is the value. That's the raw numerical data. And so if that number is less than 0, that's what I chose to represent that we want an X there. Otherwise, we simply do the conversion to a string. So we take that number and turn it into the count up or count down number, and then turn that into a string. So this code right here builds up an individual row, turns a row of integers into a row of strings. Again, you see the Java setup part. You can see that the map part here is a little bit longer and more complicated than what we've seen before. That's why I wanted to go through this example, and then the collect part at the end. Just to make sure I've dotted all the I's and crossed all the T's here, Notice in this case, because we have more than one line of code, we have the blocks, we have the opening curly brace and the closing curly brace. So your map function can be as complicated as you want. You can add as many lines of code as you want if you set it off with those curly braces. And you can put if statements in it and function calls and all of that stuff. And then finally, so here is doing each individual row, so then we have to take those individual rows and collect them back together into a two-dimensional array. Now, like I said earlier, is this any better than a nested loop? Maybe, maybe not. It's probably complicated enough that if I were to do this for a company, I would just go back to the nested loop. Another thing you might be asking, so here I'm iterating over the data itself. Here I'm iterating over the indices and then accessing the array. And you might wonder why I did that. I did that because I needed the row number for display value. If I didn't need this index, if I didn't have half my rows counting up and half my rows counting down, then I would have had an arrays stream in both places, and this would have been a little bit cleaner. So hopefully that gives you a better idea of what map is used for and give you a little more comfortable feeling that, hey, this might be something you want to use in the future, as opposed to being a really complicated way of doing something you already know how to do. I think what you'll find is an opportunity to use it in the future and dig in, even if it's not right there at your fingertips. And at that point, whether it's in the fall or the winter or next year, and you've got that real example in front of you, then stop by my office, send me an email, and we'll look at it together then. That's usually the best way to learn, is with something that you are actually trying to accomplish and you're solving your own problems instead of one that I made up for you.